Welcome and thank you for joining us today for the Precision Dairy Farming from Hooves to Harvest webinar series. This project is brought to you by the UVM Extension Northwest Crops and Soils team and is sponsored by the Vermont Agency of Agriculture, Food, and Markets. Today is the final session of our series, and we have had an amazing lineup of speakers from all over the world. All of the sessions have been recorded and will be posted to the Northwest Crops and Soils program website under the conferences and event tabs. So if you've missed any, you can find them there. There are water quality credits and certified crop advisor credits available for each session, and we will share the link and QR code for this session at the end of the series, or at the end of the presentation, excuse me. And there will also be 3 poll questions throughout the presentation. So if you could take a second to answer those as they pop up on your screen, we would greatly appreciate it. We are thrilled to have Dr. Muthu with us today. He's joining us from Germany, but he is a professor in weed ecology and management at Texas A&M University. His expertise is weed science and agronomy. The threat of herbicide resistance is immense in broad acre systems, leading to loss of effective herbicide options, increased herbicide use, and unintended impacts on the broader environment. To this effect, the prime goal of his research program is to understand the evolutionary biology and dynamics of herbicide resistance in weed communities and develop integrated pest management solutions, encompassing chemical and non-chemical tactics to prevent and effectively manage herbicide resistance. Dr. Muthu, thank you for joining us today, and you're welcome to share your screen.
Let me go full screen now. Hey, can you hear me okay? Audio visuals good?
Yep, looks great. Thank you.
Thank you. All right, so good afternoon, good morning, everyone. As introduced, my name is Muthu Bagavathiannan. I'm a faculty at Texas A&M in College Station. What I wanted to do today is to give a very high-level overview about some of the recent technological advancements in precision weed control. Many of you may already know what is going on in the field. There's a lot of commercial technology, but also there is quite a bit of R&D in this space. So what I would like to do today is to kind of touch on a little bit about the brewing technologies, but also get into the commercial options that are available, because this is a very large, broad topic. I'm only touching on some important areas. So please pardon me if I'm not getting into several of these topics that are relevant to precision weed control. Okay, so see, this is a very exciting time because, as you hear, there has been a lot of new technologies coming to the field of agriculture. So we know about like sensors and robotics that has been used in other fields, in like general industrial areas and for general public use. But this is a very exciting time where these technologies are coming into agriculture because of a lot of these opportunities that are being presented. And it's really only possible because of the advancements that are happening in multiple different fields. For example, if we wanted to do a drone-based applications, we need advancements in sensors and the platforms, and also machine learning algorithms like computer vision, softwares, and more importantly, data handling, because these technologies generate a lot of data, high volumes of data that needed infrastructures that kind of handle the storage and the collection and sharing of all this data, and also cloud computing. So if you think about it, the advancements in all these different areas have really allowed us to kind of piece together all these tools for the betterment of weed for multiple agronomic applications, but in particular for weed control, weed recognition and control, which we're going to talk about today. So the ultimate goal is to identify weeds, based on the species, size, and what have you, right? So, and then spray or control those weeds using different technologies that are at our disposal. In this video, what you're seeing is on the left, it is a raw footage of a soybean field with, you see different weeds. And this is just a proof of concept. On the right side, we have the weeds recognized as different species based on like the different colors and also the size. So with this kind of ability, what we can do is we can have a suite of management tools. I mean, it could be different herbicide options, or it could be chemical and non-chemical options like laser or mechanical tillage, mechanical pulling or what have you. And we can specifically target each individual weed plant using a different methodology. It could be, let's say if we have a resistant weed, weeds resistant to glyphosate, we should be able to identify that particular individuals that are resistant and then spray a herbicide that is going to be still effective, while still, glyphosate can still be used on weed plants or species that are still susceptible. So again, I mean, this is a kind of an idea, and the whole industry is moving towards this type of see and spray type technology that takes into account individual plant level characteristics. The same way, let's say you have a weed that is a little too large, something like what we are seeing here. That plant may require a higher dose of the herbicide than a small seedling, right? Because I mean, we know that larger plants require a higher application rate as the label recommends. And how do we achieve that in a field with varying growth stages? Again, these precision technologies would enable us to do exactly the same. So now, the technological advancements are happening both with aerial robots, the so-called drones, and also ground robots, or ground rigs, or ground-based platforms that allow us to use these precision technologies. So the question is, which one should we be using? Either drones or ground vehicles or ground platforms, or both, right? So in my opinion, it really depends on the context and the specific operations. Drones have been shown to be very useful, especially in situations where you have very sparse weed populations towards the end of the season, where driving a ground rig throughout the large fields can be not very efficient, right? And also in situations where we cannot access the field easily using ground rig, or the field is wet, then drones can be more useful from that standpoint. But in terms of the application of herbicides early in the season, let's think of a row crop like soybean or corn or cotton. The herbicide applications early on are probably more efficient with ground-based platforms, because it's very easy to target those weeds that are small. The crop is also small, whereas spraying herbicides from drones, at a certain height may not be, accurately targeting the weeds. Whereas at a mid to late season, where you have weeds particularly growing above the crop canopy, and they are like very sparse in density, that's where we found drone-based herbicide applications very efficient and convenient compared to ground rigs. Again, I mean, there could be other specific situations where one platform might be preferred over the other, but technically both are kind of used in a complementary fashion, rather than this is really not a redundant or replacement to the other. Okay, so the first thing that needs to happen before we use either of these platforms is the ability to recognize what we have in the field, right? So it's called field recognition, and map the fields or map the beats across a large production field. Now, if you're using a drone-based application method or drone-based bean management, we can use a, just do a flight first and then map the entire field and then come back and spray, which can also be done with a ground-based herbicide application. First, we can use a drone entire field where the weeds are, and then send a ground platform, and it can only treat the areas where the weeds are present. But the additional ability with the ground platform is that we can just do on-the-go detection and spray, which may be more efficient in certain circumstances. At the same time, having a full view of the field with a clear understanding of where the weeds are present across a field scale, which is a mapping the entire field, can be beneficial in certain cases, especially for decision making. For example, if you wanted to know how much weeds are present beforehand to make certain decisions as to what herbicide to use, or maybe like what kind of thresholds you want to apply for weed management. So those kind of decisions can be conveniently made if we already had a map of the weeds across the entire field. Whereas with the real-time see and spray, we may not have the entire field map, but the data collector can be utilized for generating maps after the fact and also making decisions for future herbicide applications. So regardless of whether you are mapping first and spraying or like spraying real time, these are presenting some real opportunities for effective weed control in production systems. In terms of approaches to how we recognize weeds, I don't want to get into the specifics of different technologies being used, but in a nutshell, they can be based on reflection characteristics, how different weeds, the color differences or reflection that are captured using a sensor. Could be other sensors like LiDAR, which is used to kind of like map fields, vegetation, getting 3D point clouds. And also the more recent advancements in machine learning, computer vision and machine learning, just like how we learn to recognize a particular weed plants. We look at them and then we kind of learn, okay, so this plant has long leaves or certain characteristics. The machines can do the same thing through machine learning. And it's called, just like we have brain networks, neural networks in the brain, there are also artificial neural networks that computers can use to remember different features of weed plants. I don't want to get into this detail, but again, the artificial neural networks, like our brain, the computers can also utilize different features of plants and remember them for future recognition. So in general, if you want to use computers to recognize a particular weed, what we need to do is we need to teach them how to recognize them. We need to teach them what is a particular plant. For example, if you're showing images of dandelion, what we do is we take lots of images of dandelions and then show it to a computer with the proper labeling that, okay, so this plant that you're seeing is dandelion. And if you're having the same plant with another crop background, for example, in corn, you show, like images of corn, so it recognizes corn plant, and then we have a combination of two. So you have the image of dandelion in a corn background, and we can create different variants of dandelion plants, at different growth stages of corn. And also, look at different biotypes of dandelion, because some might be tall growing, some might be short, and also different biotypes of cone. So this whole process is called, machine learning. You just train, have the image data set to train a model, and then the computer using that model will be able to detect any new images that you show them, and correctly identify what is this dandelion plant and which one is the corn plant. So this is an example of how this wheel recognition through computer vision machine learning can be applied. This is on the left, you see a raw image. It's just an RGB, this digital image that was taken using like a regular DSLR camera. And you can see different plant species in that mixture. These are basically a bunch of weeds that were present in a fallow ground. And then to the right is the computer vision, like a machine learning application to detect those different species that were present in that image. So you see different species are identified using or recognized using different colors that you see in that image. The computer vision is very powerful. For example, I want you to pay attention to this orange color little dots. These are actually a weed species called prostrate spurge. So it's a very tiny seedlings of the spurge weed. It's very hard even for a human eye to see where those plants are in the raw image on the left. See, in the RGB image, you have a lot of weeds, but it's kind of hard to know where exactly they were present. But then with our machine learning, we're able to precisely detect where those little plants are. Now, if we have a prescription or a management plan where, okay, we want to target those specific weed species with a specific tool, it could be a herbicide. If it is a sedge species, for example, you might want to spray a different herbicide than what you would spray for other plants, just as an example, right? So you can actually select the specific management option on those specific group of plants. So you could even do it on an individual plant level. So that's the power that the machine learning is going to allow us to do. So, like I said, the most important requirement here with machine learning is a large image data set, right? Because we have to train the models. We have to teach the computers with a lot of images of those individual plant species, crops and weeds. So the computer remembers what a species will look like, not just like a few images, but a lot of images, right? Because the weeds may look differently in a different soil type, or maybe in a different environment. You have a drought environment or a nutrient deficient environment. So there are different variants of that particular plant, crop, as well as weed that can happen in the field. So in order for the model to be very robust and accurate, that can be applied across multiple field environments, we need huge image data set that captures the variability that is present within that species. So what we do here in order to have such a resource in the US, we are working as a team to generate a national weed and crop image repository that it also includes cover crops, cash crops. This is a collaborative effort led by USDA ARS, Dr. Stephen Mirsky here at USDA Beltsville, and Dr. Chris Robert Houghton at NC State University in Raleigh, and myself at Texas A&M University, and also collaborating with folks at Aarhus University in Denmark. So this is a collaborative effort where we are collecting images of a lot of weeds and crops in controlled settings like this, grown in pots, as well as, so this is a more recent system that is being utilized for like periodic image collection of those crops and weed species. We're also doing an image collection in the field itself for weeds that are a little larger. We go to the field and collect images. So right now we already have a large image data set, but this is has just begun last year, and we are collaborating with a lot of researchers across the US. In major, particularly in major crops like soybean, corn, and cotton, and it will be expanded to other crops and weeds as well. So this will be a open source resource that will be important for training models for like machine learning applications. And this will also spur innovations in the private sector, because if a company wants to get into precision weed control, so one of the major bottlenecks right now is the access to these large image data sets. And it's, in a way, it's also redundant, because each company that is in this space, they have to create their own image data set, right? So it takes a lot of resources, time, and having this open source data set available to the industry and university folks to utilize, we are hoping that it will really spur innovations, and we'll be seeing even more technologies coming to agricultural weed management in the near future. Once we have these images, then we can actually generate even more complex scenes, like combinations of different weeds in a particular crop. So these are all called image synthesis. For example, you can take a look at this particular image where we have a particular soil type, and then we can place the crop. This is the cotton crop. You can place the crop, different weeds in a mixture, right? If we want certain grasses and certain broadleaf weeds, we can do that in whatever arrangements that we want to create artificial images that can then be used for training models to make them more robust. So these are really great resources that are available right now. And with our image repository and the ability to create synthetic images, the opportunities we have in the near future are tremendous. This is an example of how the machine learning algorithms were applied to detect different species in a crop field. So we have random plants, the cotton and morning glories and grasses, and after training the model, it shows the accuracy. So we were able to get like more than 95% accuracy in detecting these different species. Again, this kind of ability is fundamental to applying whatever management tactic that we want to do through precision manner, right? So once we know what exactly we have, what species, what growth stage, and things like that, then we can target our management to an individual species. This is another approach that we are taking to increase the training images. This is called virtual fields. We can actually create a 3D image of a production field with, again, different growth stage of the crop and the different combinations of the weeds. If you want like a certain grass species or broadleaf or whatever species you want in whatever combinations and whatever soil type, if you want to simulate some cover crop residues, we can do all those things and create 2D cross sections for training the models. Again, these technologies are allowing us to improve our model training for weed detection. This is another example of how we were able to apply the trained models on, to like a video like this, right? So this is detecting Poa annua. That's the annual bluegrass, which is a very common weed in turf systems. It was applied to Bermuda grass turf. Again, just an example. We could do the same in crop fields or whatever crop systems. Once we have a well-trained model, that's what we are able to do with these technologies. And right now, these technologies for plant recognition are being developed, and the companies are very advanced for certain crops where there is a major market, certain crops and for specific weeds. But for the most part, the way how the technology works right now is based on just the crop recognition, and everything else that is green, but it's not a crop, are considered weeds. So and then you just go and spray, all weeds, just leaving out the crops. So that is the current state of the art of the technology. But moving forward, as we have more and more images available, more and more training could be done, then we will be able to target individual plants or individual species. I believe the current technology that is commercially available right now mainly focuses on just like identifying where the crop is and then spray everything else that is not the crop. And we're also making progress in terms of biomass estimation of plants. So this is a PlantsMap 3D project. Again, it's a collaborative project as part of Precision Sustainable Agriculture Research Network, as well as GROW. Again, with USDA, NC State, and Texas A&M collaboration, we are working on developing a real-time system for plant biomass estimation. The benefit of a system like this would be that we can actually estimate non-destructively the biomass produced in a particular area. This can be for cover crops. For example, if we have cover crop field with just placing a sensor on a tractor that is driven through cover crop, especially while spraying for termination, we can collect images and automatically map how much biomass was produced in that particular field. If it is for forage fields, you might be, a lot of you might be interested in, how this technology can be used for forage estimation, right? Forage yield estimation. We could do the same, the sensors can be mounted on tractors or other platforms. And as you fly or pass these sensors across the field, it can automatically map the amount of biomass that is produced in that field. So these are technologies that are being currently developed. So one of my PhD students here, Joe Johnson, he's evaluating different methodologies for that biomass estimation through three-dimensional approaches. Okay, so moving on. So far, I gave you a quick overview about our plant recognition, right? What are the current state of the technologies, mainly in terms of the use of machine learning, using multiple variants of images. And once we have that capability, and once we are able to detect individual plants based on the species, the size, and other growth characteristics, then we can target those individual plants with different tools that we have at our disposal. In the next few slides, I want to quickly touch on what are the current developments in terms of management, right? So how do we target them? So I want to get into drones as well as ground platforms. With the drones, we're talking about precision technologies, but even broadcast applications of herbicides using drones has been so valuable for especially in areas where there are like very difficult to access using ground vehicles. Just think of like weeds in aquatic water bodies. How do we like control them? And it's very hard to access, or even places where they're like very difficult to access. There are some invasive weeds in like forests, and maybe it's very difficult to spray those areas with like a ground vehicle. So in those areas, or those kind of applications, even if it is just a blanket broadcast application, not so much about like a machine learning or precision spraying of individual plant or individual plants, but these broadcast applications using drones are still very valuable and have been used today for treating these weed species. And this is another application that has been very popular in the rice country, particularly. I'm amazed to see how much of especially pre-emergence and early post-herbicide applications are happening in India and other parts of Southeast Asia rice production as we speak right now. Because the alternative method for spraying herbicide is like walking inside a rice field, which, you know, the rice paddy, it's difficult to walk, or even like using ground rigs is very challenging. So in these situations, drone-based herbicide applications are like very convenient and have been readily adopted by growers. It also brings up another question. So in those places, the farmers are not necessarily tech savvy, right? Because being able to operate a drone, getting proper licenses, and that can be difficult. Or, well, A, it can be cost prohibitive. B, you know, the technological know-how can be difficult for farmers to get, especially in those areas where, you know, like people may not be very educated, or they just don't have the time and means. So so what they're doing there is there's a lot of new you know, commercial operations. It's called like service providers in most of the Southeast Asian countries, and those service providers charge per acre basis and provide the application surveys. And we are seeing this kind of business model picking up in the US as well. In fact, especially in Texas, there is a growing interest in drone-based herbicide applications in rice. I'm hearing, you know, the same trend in other parts of southern US for, you know, herbicide applications in rice paddies. This, you know, this technology, I'm just giving it as an example. This is being very convenient and being utilized throughout the world for, you know, this is like very low-hanging fruit, no, you know, like a machine learning-based detection. You just, you know, like fly the drone, spray the herbicide, and call it done. But it's becoming very convenient in certain situations. So here in the US, we are particularly excited about the use of drones for controlling weed escapes at the time of crop harvest. You may be wondering, so what is the benefit of spraying weeds right around crop harvest, right? So these are the weeds that have escaped control during the cropping season. Either they have resistance, either they have resistance, or they just, you know, were not controlled from like early to mid-season applications. Even though the crop is ready to, you know, like mature, not controlling these weed escapes can be costly if you think about how much seeds are produced from those escapes, and, you know, how much seed are added to the soil seed bank and future weed problems. So keeping this in mind, we are doing quite a bit of research using drones to fly over a crop field, map the presence of weed escapes, and then spray them on, you know, like targeting individual plants. Can show you this little video here. So this is a drone-based herbicide application. So just spot spraying escapes of pigweeds. So it's a very problematic amaranthus species. So this particular one is a water hemp. It's in Southeast Texas. It's really a major weed in addition to palmer amaranth. So this is a cotton field. You can see the weeds that were present in the field. What we did was we flew the field first using an RGB camera mounted on a drone, and then using image analysis, we identified different you know, weeds that were present in the field, and we were also able to extract the specific GPS coordinates because we used what is called RTK GPS, that is like very precise. You can get like sub-centimeter level precision, and get those GPS coordinates, create a shape file, and add it to the spray drone. And the drone can go and spray those individual spots automatically without us having to manually control. So this is a very advanced technology, but it's already there. It's coming to the market pretty soon. So these technologies are allowing us to precisely target those late season weed escapes and prevent, you know, the seeds from going to the soil or viable seeds. The same technology is being tested in rice, I mean, in multiple cropping systems. This one is a rice field in Texas. I don't know how many of you are familiar with rice, but anyway, so again, when you have the weeds above the crop canopy, we can like map them and then spot spray those individual patches. So the advantage here is if you were to treat the same weeds using ground rigs, we have to drive through the entire field, so it is not efficient. And secondly, this is a rice field. It's easier to fly than drive through a rice field with the water standing in there. So that's becoming very handy and convenient. There are some challenges with the site-specific treatment using drones that are, currently being, investigated and like being addressed. Some include downwash effect. For example, the drones, they produce a lot of wind turbulence. It can be good or bad. It is good because data shows that the downwash actually opens up the canopy. So you get the herbicide penetrating through the canopy and then get like a good deposition, especially on the lower side of the leaves. So it can be beneficial. But it can also be problematic if you have like a tall growing weeds because the like the downwash effects can create wobbling effect, and some of the branches may not be within your target area. So that is something that we've observed. And also, specifically or precisely targeting the weeds can be a challenge at times. It's called off-center, especially when you are in a windy situation, right? So when you're spraying with a drone, if there is a significant wind, what happens is, a substantial portion of the herbicide goes off target. So there are opportunities to improve this the accuracy of targeting our specific area by taking into account the wind speed and other weather parameters. So these are areas for continual research and development. But the technology is very promising for site-specific or spot applications in different systems. Okay, so these are some of the commercial systems that you may already be aware that kind of use some sort of see and spray type technology, right? See and spray is, you recognize the weed, either, you individually detect the weed species, or you recognize the crop and then, identify the weeds based on the elimination of crops, which is where the current technology is. So here I've listed some companies that are that have commercial versions. The first one is Blue River John Deere See and Spray technology that many of you might be familiar with. They have See and Spray Select and See and Spray Ultimate. The Select and Ultimate, they both are useful in a fallow situation for green on brown detection. So you have weeds and no crops, just detecting wherever green material is, and then it sprays on the green plants. And the second one is See and Spray Ultimate, which is which is effective in a crop background. So the See and Spray Ultimate is a green on green technology. Similarly, BASF has this digital ag wing Zarvio. Then they have a collaboration with Bosch. They have what is called One Smart Spray. They have been field testing throughout the US, and we are doing one of those tests here in Texas. Again, so these are trained to recognize weeds in specific crops. Again, it's green on green, still based on crop elimination technology at this point. Then Bayer has their own See and Spray type technology. It's called Magic Sprayer. Again, a similar idea for recognizing crops and spraying other green vegetation. Green Eye Technology is another company that have been already selling the See and Spray sprayers, and Verdant Robotics is a startup in California. They're mainly focusing on organic systems there, and they're also expanding into other row crops. And this is only, a short list of companies that are into the commercial space, but there are several other companies. Some are small than others. But this technology is, in the next few years, we will see a lot of new companies in the space, and this is really becoming mainstream. This is Verdant Robotics. Like I said, they're a company in California, startup company doing a lot of organic herbicide applications. So they have a pretty neat see and spray system. So this is a small system that they put on a robot called Amiga robot. So this was developed by FarmNG, the robotic platform. And so this is more of a research scale system, but it can also be useful in smaller operations, right? So if a farmer has, for example, only few acres, you don't necessarily have to buy a large tractor, that can be cost prohibitive. And this is where the swarm robotics is another topic that can be, very convenient, because swarm robotics addresses the the challenge of the scale of operations. For example, so we have these technologies. If we have it in a large ground rig, can a small farmer use this technology, right? If they only have a few acres. The advantage with the swarm robotics like this is you can have like multiples of these little robots go into the field. And if you only have 2 acres, maybe all you need is one of these small units. And if you have 10 acres, you can buy a few of them. And this can be scaled up across, from a small acre all the way to thousands of acres. So the swarm robotics, it's another space where a lot of technological advancements are happening right now, because that involves robot-to-robot communication and how they coordinate different activities autonomously, and also human-to-robot coordination. Again, don't have time to get into that, but these are exciting times where advancements are happening in the swarm robotics as well, which really will allow for scaling these technologies at multiple field sizes, even like as small as a couple of acres. Okay, so this is something that I had an opportunity to see in the University of Sydney. It's been tested at the University of Western Australia, and also a few locations across Australia. I also heard one of the researchers here in Mississippi is developing a similar system. So this is called weed chipper, just like a see and spray technology, but instead of spraying, we are using a hoe to just chop off the weeds. Let me play this video so you get an idea of how it works. All right, here it comes again. Okay, so as you see here, this is pretty neat. But so in a fallow situation, you don't have to till the entire field, especially if you're in an area where you have like large lands and you just need to chop a few weeds. This can be pretty handy. It's really good for protecting soil, less erosion this way. Again, the technology works similar to the herbicide spraying, right? So first you have to recognize the species. If it is in a green on brown situation like this, in a fallow ground where you don't have a crop, you just have to identify wherever there is green color material. So that will be considered as a weed that needs to be removed. Whereas if you are in a cropping situation, it's a green on green type scenario, and just have to identify the species based on so whatever approach we are using. And so this is a commercial system called a company called Carbon Robotics. They they have been, so this is an excellent technology for weed control using lasers. And let me play this video and you can see how it works. It's another similar to see and spray, but it's see and burn, basically using lasers. Okay, so with this, they are getting very high accuracies of weed control, and they've already sold several units in California, I believe, and also a couple in New Mexico. They're mainly targeting organic vegetable production, where the farmers can afford these kind of units. Because what I heard was each of these machines cost about $1 million. So it is definitely a little pricey for a like a average cropping operation. But for like specialty crops, high value crops, especially organic systems, that's where their primary market is right now. But as the technology matures, there could be like systems that can be more affordable for row crop production. But I do want to mention that one of the limitations with the laser reading, that at least what we've observed in our prototype testing in Texas, is that the laser technology is the most effective on the smallest weeds. So you got to have the weed seedlings. So you have to hit them when they are less than 1 inch, like little seed cotyledons to 1 to 2 inches. That's the maximum size it will be effective, especially on grasses. If the grasses are more than like 2 inches tall, you're not necessarily killing the growing point, which is closer to the ground. So then you start seeing the regrowth. So hitting the weeds at the like 1 inch or less size can be pretty challenging if you're in a high rainfall environment, because especially the size of the unit, we couldn't get to the field when the field is wet, right? So if it's anything like southern US, Texas in particular, if it rains and when there is enough moisture and there is enough warmth, all it takes is 2 to 3 days for a weed to grow from 1 inches to 4 inches, so it can grow pretty fast. So, but in drier environments where, you are able to operate the machines 24/7. So those are the conditions where the laser reading has a high success rate, because you can run the machines 24/7, so you can hit them when the weeds are still small. Regardless of the species, the laser does an excellent job of burning them. But again, the cost is something that would have to come down. But as technology matures, it might. So this is electrocution. It's not so much precision application, but the electrocution as a technology, it's also showing very promise as a non-chemical weed control option, especially in organic systems. So this is a unit that is currently being used by an organic peanut producer in the Texas High Plains. Let me play the video so you can see how it works. So it's a very high voltage electricity. So this one generates about 12,000 volts of electricity. You can see how it completely burns the weed as it's going, above the canopy. So use a metal bar here that when it touches the weeds above the crop canopy, it completely kills it. It's been very effective. There is still factors like soil moisture, plant moisture, they play a role of being investigated. There are also systems that are inter-row systems. So this one is above the crop canopy system. We are working with companies, like Zaso, so let's say electrical weed control unit manufacturer based in Switzerland. They also have a big operation in Brazil to develop systems that are like inter-row. So these can be some alternative weed control solutions that are in the horizon. We're also using these technologies not only for weed detection and management, but also for some other applications like like mapping and estimating weed seed production in a crop field. So once we kind of have an idea of how much seed is going back to the soil, we can have a better management decision this season or even like next season, because that to expect more weed densities, and maybe you can do variable rate pre-emergence applications to the soil using these maps. We're also looking into, just similar to detecting individual weed species, the question we're asking is, can we detect individual herbicide injury symptomology that can happen when there is a drift situation, or even like there's a misapplication? So this is one of my PhD students, Baldo, is working on recognizing the signatures, unique signatures of different herbicide modes of action, and hopefully one day we will be able to like fly a drone and then identify what herbicide had caused the injury, and also evaluate potential yield loss that will help with management decision making. Okay, so we're coming to the end of this presentation. In summary, the global trends in weed issues with weed adaptation, herbicide resistance, and all other issues really necessitates the use of advanced technologies. They are coming in very handy. They not only provide new solutions, but also can make farming more convenient. The site-specific weed management is going to be very efficient because it helps reduce the herbicide use, and it helps target individual plants with specific management tools. And they're also, in the future, they will also allow us to use certain herbicides that were not possible with a broadcast application due to environmental load and other restrictions. So this is an area that we are particularly excited about, because so there could be some herbicides that are on the shelf right now because of like unpreferable environmental profiles when you apply as a broadcast application throughout the entire field. Whereas if you used it a more site-specific fashion, then your environmental load is reduced substantially. So there's still a lot of questions with respect to how it's being handled by EPA and like different products and all those things. But it is certainly an opportunity that is provided by these new technologies. And even without precision applications, like I mentioned, just broadcast applications using drones can be very beneficial in specific situations like rice fields, or like applications in water bodies and other situations. And again, do we really need advanced machine learning for detection? It really depends on the situation, but moving forward with the technological advancements, that is going to be mainstream because it gives us more robust solutions. But early on, even like simple weed detection based on color differentiation or height differentiation, those things can be used for like very specific applications. The challenges do remain because this is a fairly new field with a lot of questions than answers, but the future is very promising, right? So it's just amazing within the past 5 years how much we've been able to accomplish just in the past 5 years. So it's for like folks who are in this area, who are like researchers. It's really difficult to keep up with because every day there's some new development, and so we have to constantly, like catch up with what's going on, which is actually a good thing because it only means that in the next 5-10 years, there's the entire agriculture. So we will see, the use of chips in general will be very commonplace. So you wouldn't even know the areas in which these technologies are. They will be like very commonplace, and I think that's that is a good sign for agriculture in general. But we shouldn't forget that the weeds are always smart, and they will adapt to whatever management that we do, right? If we didn't do it with the stewardship in mind, if we didn't rotate our options, if we didn't diversify our options, the weeds will adapt no matter what. And the precision technologies are no exception. Okay, so we can easily predict a forecast that if folks use, the computer vision to detect the weeds can get around those computer vision, right? So weed adaptation to these tools at multiple levels, whether it is for the management actuator, whether it's like a laser or a herbicide, that's one thing, but also how the computers see and recognize the weeds. There could be resistance to that or adaptation to that. So those things are very possible. So we have to always keep in mind that weeds are smart, and they will and can adapt to any management if we relied on it heavily without sufficient diversity. So with that, I would like to thank our students, staff, as well as collaborators who have participated in a lot of these research activities that we have been doing are doing in Texas. And thank you. I would like to hope we have a few minutes for questions.
Yeah.
Thank you. Thanks very much for the opportunity.
Thanks for speaking today. If anyone has any questions, they can put them right in the chat. I had a question. Let's see here if I can get my screen up. All right. I had a quick question about the drone technology, and I was just curious, in developing the weed identification and spraying technology, how frequently the drone needs to be flown and used in those cropping systems as people start developing, as this technology comes available and people start developing protocols for using this technology. And along those lines, if you have thoughts about the cost or economics in using drone technology in commercial cropping systems.
Thank you. So the frequency of use really depends on how frequently we need to, do a treatment. I would say just like, regular field scouting, right? If it is in Texas, people typically do like scouting once every couple of weeks, right? So instead of manual scouting, we can use drones to replace manual scouting. So I would say it's the same frequency as your manual scouting. So now you're using a better technology to get a more accurate evaluation of your fields. Yeah, but in terms of the cost, it's really difficult to put a number. But let's say, if you have your own drone, the drones are not that expensive, right? So you can get a DJI drone with even a multispectral sensor for about $5-6 grand. Or if you just want to like RGB, a really high quality RGB sensor, you can get it for like $2,000-3,000. So or even cheaper. There are other brands. So it's not that expensive to fly and get a footage of the field, right? And then there are some commercial service providers who also offer you software along with the drones, because getting a footage is one thing, but trying to extract information from the footage is another important step. So those subscriptions can be, I couldn't really tell, but if you have like a land, large enough land area, and then if you do it multiple times a year, it would be, honestly, it will be cheaper than manual scouting. and more accurate, in my opinion.
Thank you.
Sure.
There are a couple questions in the chat. With the laser and other techniques where you burn the weeds, is there risk of fires spreading, or is it generally well controlled?
Yeah, that's a really good question. So wherever they've they've tested this, they're mostly in a like a non-cover crop situation. But if you have cover crop residues in the field, I would expect there's a fire risk. Yeah, I don't know if they've even tested tested that, but that is just my gut feeling. Yeah, there might be a fire risk in that situation.
Heather's question was similar. I said most of the fields we saw were low surface residue. What about high residue fields, like such as corn stover?
You mean for weed recognition spraying,
And
or
well,
for?
using those technologies that like zap or burn the weeds.
Yeah, Zapper, that's another good question. We are going to test it this summer as soon as we get a unit. Yeah, I mean that's a fantastic question. We just don't know, but there is well, we can already see based on what we observed in other like a non residual situations. It actually gives like a flare of fire when it touches the plant. So yeah, I want to I want to say that there is the fire risk is real.
Yeah. There must be some consideration for wind speed or presence of wind when you're using those technologies.
Right. You mean for the laser in particular, or maybe just like a drone?
I guess all of it, but
Yeah, sure. So if you're using like a drone technology, there is definitely like a wind speed considerations, because the ability to fly and then also hit the target with the applications. So we really need to watch the wind speeds. With the ground rig, I mean, it's also a significant factor, but you probably have a little more flexibility with the ground rigs because of the height between your nozzle and the canopy is being much closer than with a drone application.
sure. There's one other question in the chat. Any ideas on how EPA is planning to address label language disparities moving forward regarding UAS drones?
Sure. Yeah, so I don't know if I'm an expert to speak about that, but I do know that EPA has been working on this, because at this point the labels, you go by the labels that are applicable to aerial applicators. If you're using a like a fixed wing planes or helicopters, I think those are the um, like guidelines that are currently available, but EPA is working to come up with the label language for specifically for drone-based applications. So hopefully in the near future.
Great. Thank you so much. We really appreciate your time. Thank you for joining us today.
Well, thank you very much. Thanks again, everyone. Thanks for the opportunity. Good luck with these new technologies. So it's very exciting. It is suddenly an exciting time.
Thanks,
Thank you.
Muthu.
Thanks, Heather.
Hey,
Thanks, everyone.
I had a